Hi Geometry. We are going to be doing a crash course these next 2 days on circles. So we're about to go through a lot of information and I'm going to try to just give you what you need to know. So let's get started. The first thing we talk about when we learn about circles are all the different parts of a circle and the lines that we need to know. So what is a circle? A circle is a set of points, so all the way around the circle are points that are formed, or that are an equal distance, rather, from the center. So all of the points that go around a circle are the same distance from the center. That's why if you tie a string to a pencil and hold the string down and then run the pencil around tight all the way around, it forms a circle, and that string represents the same distance all the way around. And in a circle, that's called the radius. So from the center out to the outside or touching one point of the circle is called the radius. All the way across is called the diameter. If you just have a line inside the circle that connects on 2 points of the circle, so the endpoints of that segment are on the circle, that's called a chord. You might not have learned that before, I'm not sure. Now, if the lines continued outside of the circle, so like this is a chord right here, but if it continues on in either side, that's called a secant. And then we're going to talk about this line that's very important. It's called a tangent line. So let's not get this confused with sine, cosine, tangent. Here we're talking about a tangent line. And a tangent line is a line that shares exactly one point with the circle. And that point is called the point of tangency. So you see we have this line and it is touching the circle at point B, which is the point of tangency. AB is a tangent ray. It also could be a segment as well. So we'll look at different ways to name these. All right, so let's practice this. It says, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle C. So this is how we name circles, by the center point. So it has the symbol for a circle and then the center point, which is C. So that's how we name circles, which is kind of interesting. So AC right here, that is the radius. Okay, so a radius, and if you have multiple radiuses, it's not called a radius. It's called radii. It's plural. That's what I'm trying to say. So if you have multiple, the plural of radius is radii. There we go. Okay. AB. Okay, that goes all the way across, so that's the diameter. Ray, DE. Ooh, so DE touches it one time, so that's a tangent ray. And then AE. AE goes through the circle, so that's a secant line because it intersects the circle on either side. Okay, in example 1, what word best describes AG? AG. Oh, that is a chord because its endpoints are on the circle. It doesn't continue outside like AE, which was a secant. And CB. Oh, CB is a radius. And there are multiple of these. There are an infinite number of radii in a circle. It goes all the way around. Name a tangent and tangent segment. So a tangent could be DE, like this. And a segment could be DB. Because it's a segment like that. All right. Now, when you have a circle on a graph, you have to know how to like name the length of the radius or the diameter. And so it's really simple. You're able to just count it. So if we look at circle A, that's this first one. And if you go north, south, east, west, you see that it hits exactly on the circle, which that will help you find easily the radius. Like if you had to count from here to here, you'd have to use the distance formula, or from here to here, you'd have to use the distance formula because it's not an exact point. But when you just go north, south, east, west, you can easily find the radius or the diameter. So the radius of this circle is this distance. Any of these are the same. So 1, 2, 3, or 1, 2, 3, or 1, 2, 3, or 1, 2, 3. So the radius of this one is 3. The diameter of circle A, well, that's all the way across, so that's 6. You got 3 on either side, so that's 6. The radius of B is, again, so from the center, north, south, south, east, west, doesn't really matter, but it's 2, right? Either way, it's going to be 2. The diameter of B then is double that, 4, which is why you can have 2 formulas for circumference. Circumference equals pi times diameter, or circumference equals 2 pi r, since the diameter is the same as 2 times the radius. So this and this are substituted. Anyway, it says for this next example, use the diagram in example 2 to find the radius and diameter of C and D. Okay, now C and D are inside of each other, and they're not concentric circles, because concentric circles mean they have the same center, and the point C and D are not the same. So, I'm sorry, guys. So, let's see. So, C, the radius is... Oh, the C is the big one, so that is 1, 2, 3. And that would mean the diameter is 6. And for circle D, 2 and 4. Okay. This next part's not very important. Tangent lines and circles. So I'm just going to go through these examples, and I think you'll be able to catch on. It says, tell how many common tangents the circles have and draw them. Okay, so these 2 circles in example A, I can draw 4 common tangents. Oh, I'd left the answers on here. So 4 common tangents. You see right here's one, and here's one. So what these have to do is they can only touch the circles once. So it touches it once, touches it once. And then if you drew them through the middle, this one touches this one once, and this one once, and this one touches this one once, and this one once. And they have to touch both circles to be common tangents. Like if I just drew this one right here, that's a tangent, but it's not a common tangent because it's not shared with the other circle. So common tangents mean that it has to be shared with both circles. Okay, in the next one, you have only three, because of the fact that those are touching in the middle. There's only one line that you can draw through there. And then these, because they're overlapping, there's only 2 tangent lines that you can draw through there. Now, drawing tangent lines isn't really like a skill you have to have so much as using tangent lines. So we're going to go right to this theorem. It says, in a plane, a tangent line to a circle... In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle and its endpoint on the circle. So let's do this again. A line is tangent to a circle. Now we want to know if these lines are tangent to a circle. And so it will be if and only if the line is perpendicular. So this is perpendicular, forming 90 degrees with a radius. Now there are infinite number of radiuses, or radii rather, in a circle, but any line that touches it at one point and is straight is going to be perpendicular with a radii. So it says this is how we can use it. It says in diagram PT is a radius. In the diagram, oh my goodness, sorry. PT is a radius of circle P. So we're being told that this is a radius. Is ST tangent? So is this line a tangent line? Is it hitting it just one time? Well, one thing that we learned was that we can verify if a triangle is a right triangle or not, and we need this to be perpendicular. How do we do that? We set the sides, so we square the legs, and we set it equal to the hypotenuse, and we see if they're the same. If 12 squared plus 35 squared equals 37 squared, then it is a right angle. Remember, if it's like greater than, then it's acute, and if it's less than, then it's obtuse. So if it's equal to it, it's a right triangle. And it is. If you did this on your calculator, you would see that it is equal. So it is a right triangle. So then we know that ST must be perpendicular to the radii. So it is a tangent line. Okay. In this diagram, on example 5, in the diagram, B is a point of tangency. So remember, that's the one point where that line hits a circle, because a tangent line hits the circle once on one point, shares one point with it, and that's called the point of tangency. It says find the radius of this circle. So if I know that that's a point of tangency, then this must be a right angle. And if that's a right angle, that's a right triangle. And if that's a right triangle, I can use the Pythagorean theorem. This is so cool. So, I don't know r, but I know 80 squared plus r squared is going to equal the hypotenuse, which is r plus 50. Ooh, r plus 50 is that whole thing squared. Oopsie, sorry guys. R plus 50 squared. Now, here's some algebra for you. You're squaring that entire quantity. You are not allowed to just square the r and square the 50. It's not the same. How do I know this? How can I prove it? Watch. Let's say 2 plus 5. What is that? 7, right? Okay, cool. Is 2 squared plus 5 squared the same as 7 squared? 4, 25, is that 49? No. So when you have a sum, you can't just square the individual parts of it and add it together and say that it's the same. So even though 2 plus 5 is equal to 7, 2 squared plus 5 squared is not equal to 7 squared. So you have to FOIL that. So we get 80 squared, which is 6,400 plus r squared equals, and so to do this you do r plus 50 times r plus 50, and you have to FOIL. So first, so r squared, outside, inside, last, and then you will combine your like terms. And what's cool here is that the r squareds cancel. So then you've got 6400 equals 100 r plus 2500. Subtract 2500. And you get 3,900 equals 100r divided by 100. And you get 39. So, and these are feet. So the radius is 39 feet. So a lot of information in that problem. Very cool. You can definitely use that on your standardized tests. Now, another thing that's so cool about these is, and we're almost done, is that the tangents can sometimes be the same, and they will be the same if they meet at the same point. So tangent segments from a common external point are congruent. So see this line right here is tangent to the circle at R, so that's the point of tangency, and it's tangent to this circle on this side at T. And so those are both tangent, and because they start or they share that point at S, they are equal to each other. And that is such a fascinating thing, that if any point you had a point here and you drew a line that was tangent from here like this, and then from here tangent like this, they have to be equal, which is just so cool and super helpful to know. So as long as they meet, or as long as they share the same external point, they're equal. So therefore RS is congruent to TS. So if we take a look at this problem in example 6, it says RS is tangent to circle C and at this, that's our point of tangency, and RT is tangent to circle C at T. Find the value of X. Well, because they're both tangent, they're equal to each other. So that means that 3x plus 4 is equal to 28. So 3x equals 24, x equals 8. And there we go. All right, so a couple more examples, and then 10.1 is over. So it says, is DE tangent to circle C? DE. Well, we would know that if this is a right angle. So is that a right angle? How do we verify if it's a right angle? We can use the Pythagorean theorem. Now this is 3, so then that means this radius is also 3. So we've got a 3, 4, 5 right triangle. Now I know that that's 5, 3, and 4. That's valid because that's one of our Pythagorean triples, right? So it's 3 squared plus 4 squared. Does that equal 5 squared? And indeed, 9 plus 16 equals 25. So, yes, because it's a 90-degree angle. ST is tangent to circle Q. Find the value of R. So that's just like what I just did a couple examples ago. So we would do that R squared plus 24 squared equals parenthesis R plus 18 squared, and you have to FOIL that. So I want you to solve it, and I'll tell you right now that the answer is 7. So see if you can get 7, and if not, you can maybe try again or come ask me. This one, find the value of X. Well, hey, they're both, I know that these are tangent lines because they form right angles, right? Okay, so then, and they share this common point out here. So therefore, x squared is equal to 9. Take the square root of both sides. So x equals the square root of 9, which is plus or minus 3. All right.